Good evening, everyone. A very warm welcome, all of you, to TechTalk v3.0. It's truly wonderful to see so many bright and eager minds gathered here to explore, learn, and be inspired by the latest in cloud based technologies. We are honored to have with us Professor Vasant Priyan, Dean of Faculty of Computing, all heads of departments, and our esteemed lecturers. We greatly appreciate your presence in this session. A warm welcome to all participants and guests, and we hope you find this today's session insightful and engaging. Mr. Chanaka Ramanayaka and Mr. Savina Veerasurya, both Associate Tech Lead at Codimite. They will be joining us together to share their insights and experiences on cloud technologies, innovations, and industry best practices. We are excited to learn from their combined expertise, and I am sure this is going to be a very inspiring session for all of us. Let's invite Mr. Chanaka Ramanayaka and Mr. Savina Veerasurya to take the floor.
Yeah, all right. Thank you. So, myself, Chanaka, and here with me is Savina from Bodymite. So, first of all, thank you very much for inviting us today. So, we are here to share you our insights about our all the clouding and AI insights. And thank you very much for inviting us today. So, we are very glad to contribute with you. So in this session, there will be two half of the sessions as we have planned, me and Savina. So in the first half, we will be presenting you the core concepts of the cloud technologies, most of the technology that we are dealing with, and with some of the examples. So, and the second half, there will be more practical aspects. So you can gain, I think you will be able to gain a lot of knowledge in this session. Okay, without much talking, let me start with my slides. Hope you can see the screen.
Yeah.
Okay, all right. So in session mainly අපිට sessions දෙකක් විදිහට අපි plan කරලා තියෙන්නේ. Okay, first half එක තමයි start කරන්න හදන්නේ. Mainly theoretical concepts in cloud computing. So, okay, let's get started. So, before going to learn the cloud technologies, we'll just take some idea about why do we need cloud? Why do enterprises move to cloud these days? So, the first point is the cost. So, cost means not from just the perspective of money, it's from the money as well as the time. So, in today's cloud computing, when compared to the traditional computing of on-premises servers, the main benefit we get is shifting of CapEx to OpEx. So what do you mean by CapEx? CapEx is capital expenditure. And OpEx means operational expenditure. So for example, if you are depending on on-premise service like traditional server, you need to set up, you need to buy, and you need to configure everything from scratch. But when it comes to cloud technologies, you just need to purchase the specific subscription, and you are paying only for the usage that you are using. And the second point is scalability. When it comes to scalability, uh, cloud is the most comfortable way of doing scalable and productive applications. And the third point, and one of the main reason that we are going with cloud is to go global reach. Because let's say if we are dealing with a US customer, you can set up servers in your US region, but suddenly you want to expand it to Europe region. So then you need some servers in that region as well. Otherwise, there will be a lot of latencies with the applications that we are using. So when it comes to cloud, majority of the cloud providers like GCP, Azure, AWS, they all provide global server facilities when you are dealing with their services. So to get more idea about these points, uh, we'll have some description about each of these criteria separately. Okay, so in this section, I am explaining you about the cost efficiency, how we can make our cost efficient when we are dealing with our cloud services. So for example, let's say if you are dealing with a traditional setup, so you need to do a background research, a strong research. Let's say your company have multiple departments. So you need to go and check every department and gather every requirement in that department. And altogether, you have to have a great idea about what are the main requirements and what are the optional requirements that you need to have when it comes to creating a infrastructure from scratch. So those costing and timing includes the cost for servers, cost for setting up and configure network configurations, cost for cables, racks, everything. Plus, you need some great professionals that have good idea about this networking and server server component connecting uh, professional. So, but when it comes to cloud, it's otherwise. So you don't have any of the capital expenditure when you are going to cloud. So you are paying only for the operational expenditures. So in cloud, we have that very popular term called pay as you go. So in this model, you are paying only for the resources that you consume. You are not buying any of the resources to host your applications. You are just renting them. So hope that point is clear. And the other point, so when it comes to a lot of startups, so the startups spend a lot of money to get started with new projects. So spend thousands of dollars to set up servers, server racks, and networking stuff. But suddenly, those startups get stopped in the middle of the projects due to various reasons. So those are something we have to face when you are dealing with this industry. But when you're using cloud, the plus point is you are not buying any of the resources like servers, not even a RAM module. So you are just renting them. When you are going with cloud, the plus point is you just need to stop the renting agreement with the cloud. So you are not going to pay anymore. So you don't have any losses. So that's a one point we have to highlight. So do you guys have any questions regarding this point? Katari, questions තියෙනවා? All right, so let's move to the next slide. The second point is scalability. Scalability also one of the main point that we highlight in cloud, because let's say, for example, in the picture, you can get a clear idea. So here, I'm showing you a traditional IT environment. So in this environment, you have to set up your servers according to the spikes in your server environment. Let's say you have a lot of traffic in the midnight, but not in the morning. So you need to automate each and every server configuration depending on the time. So you need to predict them. So depending on those predictions, you are doing automation for the servers. So at the midnight, you need to scale up a lot of servers. But in the morning, you need to scale down those servers. But in case of sudden spike, you won't be able to handle that, because that is pre-automated, pre-trained model that we are using. The plus point is here, the cloud auto scaling. So when it comes to cloud, scaling is automatically handled. So for example, in GCP, we have the service called Cloud Run. In Cloud Run, when there's a sudden spike, it just takes only 5 seconds to scale up the service. It scales up with more resources and more instances. So that is the main point of using cloud when it comes to scalability. All right. The next point is the global reach. So as I explained you previously, if you're dealing with traditional enterprises, traditional servers, let's say, for example, I'm having a project in the US region. So I am setting up some servers in the US region, but suddenly there are some customers coming from my project from the Europe region as well. So in that case, it is not the best practice to use same servers in the US in the Europe region as well. We have to build an entire server centers in the Europe region as well, because we have to make sure we are aligned with the guidelines and we are providing an optimized, efficient service to the all the users around the globe. So that takes a lot of overhead to make that kind of servers in multiple regions in the globe. So that is the main disadvantage when you are going with traditional server systems. But when it comes to cloud, as I previously explained, you can just deploy. You can just deploy a new container, new service on the region that you need. So it's just a matter of seconds to minutes to reach that kind of regional services. Okay, so I have talked about the main 3 points about these aspects. So do you guys have any questions regarding that? Questions in the කට්ටියට? Okay, seems like there are not much questions. Yeah, go to the next one. So this is about containerization. So containerization is one of the main point that we consider that we prioritize when we're using cloud services, because like almost all the cloud services that we deal today supports this containerization and prioritize this containerization. So what is containerization? So it's about packaging your application with all the dependencies. The importance here is you don't need to switch entire infrastructure with the base OS. Like let's say when you are developing an application in localhost, you are getting resources and libraries from the OS, maybe Windows, maybe Mac or Linux. But when it comes to cloud, it's useless if we apply those all the libraries, services that are not using from your application. You just need only the applications and libraries that you need to run your application. So to make it lightweight, so to make it an efficient, so we can use this containerization. So in that case, Docker is the main service, main tool that we are using for create Docker images. So can you just raise hand uh, who have used Docker currently? I'm not going to ask any questions. Questions මුකුත් අහන්නේ නැහැ. Just කවුද Docker use කරලා තියෙන්නේ? Mm, seems like, yeah, okay. There is 1%, yeah, 2%. Very good. Anybody? Okay, 3%. Great. So Docker is something you need to learn and you need to try out. So it's very simple. You just need to download the Docker client and need to configure it. So it's very simple and easy to containerize your application as a Docker image. So in this image, what I am showing is the infrastructure, the layers, how Docker will work in your infrastructure. And okay, let's move to the next section. Okay, again, this is one of the crucial and the most important concept in cloud computing, the identity and access management. Simply we say IAM. So IAM is a framework, and that framework available in kind of all the cloud providers like GCP, Azure, AWS. So the main point of using this framework is the security. So this framework uses role-based access. So you may have heard and used role-based access. So the point here is we are not granting every user every access simply. So we are grouping users according to their roles, and we are granting only the necessary permissions only. So we are not, so it calls the principle of least privilege. It's one of the fundamental core concept in cloud computing. So let's move to the next slide to have clear idea with the examples. Okay. So about the IAM policies that I have mentioned you. So here is one of the example that I'm showing you to get some idea about how this concept applies in real world scenario. So let's say, so in here, sorry. So in this section, we are having a bad practice. The bad practice is, so let's say there is a reporting bot. The reporting bot, what does is, it scans some data from logs and create a report. So when scanning, it just needs V blocks, the V access, sorry, the V access. So in any of the case, if the bot get compromised, if it has more access like project edit access, so the hacker would be able to delete the entire database, delete entire logs. So that is kind of risky approach, and that is a bad practice. The best practice here is the bot only need the weave access. So if we grant the weave access, the compromised bot, even the bot get compromised, the hacker can only read the logs. No any edits, no any deletes can be happen throughout that kind of privileges. So that's the main point, what I'm going to explain you here. So anyone is familiar with this IAM roles? Have you implemented? Just raise your hand just to know. All right, seems okay, right. So this is something uh, that showed you how this process works. So there's a user group and there are policies, the IAM policies that I have described earlier, and these are the cloud resources. So the diagram explains how these user groups go through the policies and access the cloud resources. So that's the main thing that I want to highlight here. The process of working is IAM policies. Okay, so in this part, I'm going to uh, talk about some of the core services that are provided by the most of the cloud providers. So the first one is infrastructure as a service. So what do you mean by infrastructure as a service? So when it comes to IaaS, it provides you entire infrastructure like, so for example, I'll explain with this example. So if you have developed an application and if you have already ran it successfully in the local machine, so you need to do the same replication to host that. So in that case, the best approach is using a infrastructure as a service. So we have in AWS, we have something called EC2. And in GCP, we have compute engine. So when you're dealing with these kind of services, what you have to do is you have to connect to the virtual machine, and you have to replicate what you have done in the local machine. So you can just shift the code to the VM and serve it. So you can easily host your service like that. So to get an idea, other than the concept, I will show you some costing also. So this is pricing plan of GCP Compute Engine. The reason why I'm showing this is you need to get some idea how these services cost. Without getting that idea, it is not good to use these services uh, and deploy. So in this compute engine in GCP, so it have multiple machine types. So the machine types have different number of CPUs and memories. So depending on those, it cost. So higher the number of CPUs and RAM, higher the cost is. So you need to be very mindful when you are choosing these tiers. Otherwise, if you choose a big machine, a machine that have over provisioned resources, so you have to pay more than what you use. And the other point is, if you have deployed your system into this kind of compute engine instance, you will be cost as long as you are running the system. So you are not paying for what you are using. You are paying for the entire instance that is running throughout the period. So that is one of the main point I want to highlight here. So have you guys used compute engine? Anyone? Okay, seems like no one is there. Yeah, let's move to the next one. So the second one, platform as a service. So when it comes to platform as a service, it gives you the feasibility to deploy your application with minimal steps, not like in compute engine. So in the compute engine, you need to create a compute engine and need to install that and configure OS, the libraries and everything. But here, when it comes to platform as a service, uh, by using just small configurations, you can deploy your source code by packaging it into the platform as a service. So in Google, they provide Google App Engine. In AWS, we have Elastic Beanstalk. So this is pretty much simple, the software service. So I'm sure all are using these services. So this is about delivering services entirely that is customized that is customized for the exact purpose that you need. So this is not something like an infrastructure platform. So you are just using the service provided by the cloud provider. Examples are Google Workspace, Microsoft 365, Salesforce, likewise. Okay, so this is something important. Container as a service. So what do you mean by container service? So let's say you have developed an application in your local device and you need to deploy it. So as I mentioned previously, when you're using the services that support containers, you need to containerize that. Most of the time, we are using Docker. So as examples, I could show you the Google Kubernetes engine. So let me show you the Google Kubernetes engine with the pricing model. So you can get clear idea about the Google Kubernetes engine. So with this costing, you can get clear idea how they work, how they allocate resources. So in this, first they charge for there is a cluster management fee because Kubernetes is a cluster. After that, most of the time, so there are different kind of billing plans. So what I need to highlight here is the basic idea. So here they will simply charge you for the computing. So this highlights the standard mode of GKE enterprise. So it will cost for the resources that you have rented. But there is something called autopilot mode. In the autopilot mode, they will cost only for the resources that you are using actively, not for the resources that you have granted to your application. Only for the actively used resources they are going to cost. All right. So far, any questions, guys? Okay, then we'll move to the next one. Okay, another very important core concept, serverless computing. When it comes to serverless computing, it's about managing the entire infrastructure by the cloud provider. So previously we talked about platform as a service. Now this is entirely different. Serverless computing. In serverless, we are not configuring or installing or we don't have any networking or anything like that. The only thing we are doing here is we just containerize our application and deploy. So all the networking, scaling, and everything is handled by the cloud provider. So this is the main thing of having serverless services in the cloud technologies. And as a summary, so here is a comparison between platform as service and uh, serverless service. So as I explained earlier, so in the management side, so when you're dealing with serverless, you just need to apply your code. There is no configuration, no rules like this. And also in the execution, as I mentioned you previously, by showing you the GCP costing, when you use platforms, it costs continuously. But when it comes to serverless, it costs only for the usage. It costs only for the triggers that you trigger. Plus, when it comes to scaling, you need to manually configure all the platforms when you're using platform as a service. But in serverless, you don't need to worry about that. All the scaling is automatically handled. And also, again, when it comes to billing, the negative point of having a platform as service is even you are not using the service, even there are no spikes for the service, you have to pay for the idling as well. The idle cost is there. But when it comes to serverless, there is no cost for idle time. You are only paying for the request and the resources that you are using actively. So yeah, that's pretty much it about the basic theories in the first session. Uh, okay. So depending on the things that we discuss and talk, do you have any questions? කට්ටියට questions මොනවාරි තියෙනවද? අපි කතා කරපු theories ගැන දැනගන්න. If you guys have any questions, take like 2 minutes. Maybe you can discuss and ask from us. Okay, you guys can have a discussion if you have any concerns about ongoing tasks, ongoing projects, and we can discuss that. And the second half of the session will be starting around 2 minutes from now. So if you guys have any concerns or questions, please feel free to ask.
Excuse me, sir.
Yeah.
I am an undergraduate of Sabragama University of Sri Lanka under the data science stream. Then can I know what are the opportunities of future of my career according to this session?
Yeah, that's a great question. So cloud is something emerging, Yanusha. So let's say, for example, in our companies, we have cloud architects. One of the crucial roles playing in the company, cloud architects, the SecOps engineers who plays a lot of responsible roles in the company, the DevOps engineers, especially the DevOps. So in the second session, the Sabina will be explaining about the security aspect, especially. So those are the main roles that you can focus on, Yanusha.
Yeah, not only that, also the AI related stuff, since it's
Yeah.
data science model, like highly dependent on the data it's getting. So it's the fetching the data and feeding it to the model part is depend on the data science people.
Okay, thank you, sir.
Okay, seems like there are no any questions, so let me share my part. Hope you can see my screen.
Yes, Sabina.
Yeah, so this is like a real world example of how the concepts Janaka explained would implement. So in here, I have virtual machine hosted web app. So in here, I have app, and I will be using something called a reverse proxy to expose that app to the public internet. So the reverse proxy is what allows like external traffic to uh, call the internal services. So this will be like a gateway that handles the traffic and route to the internal services. So it will also do, if you have like things like SSL, it will also do that network layer security at the reverse proxy. So let's say I have this app hosted in this VM. So if I want to like create a domain, in this case example.com. So if I want to host my app in example.com, I have to buy a domain from this domain service provider, like Namecheap, and I have to point example.com domain to this public IP of the VM after purchasing the domain. So that is the way this works. But there are like certain issues with this. The first thing is we actually never do this in real world, because I'll show you why. The first thing is it doesn't scale very well. and it has a single point of failures. What I mean by that is, let's say if there are like lot of users started flooding into the app, so in that case there is the app is hosted in a single VM. So if that VM crashed, the app will be unusable. So that will be a single point of failure, and it doesn't scale very well, because the only way we could scale it is when hosting it this way. Only thing we could scale this is we have to stop the VM and change the machine type to a higher machine and start it again. So between the time we shut down the VM and start with the new machine type, the app will be unusable. So those are the concern with the hosting in like a VM in that way. And another thing is the VM's public IP is exposed to the internet. So this is also like a critical security concern, because if this IP is exposed to the internet, anyone from internet could ping to this server. And if this server has like a vulnerability, a hacker could exploit that vulnerability and potentially gain access to the VM. So for those cases, we never expose the VM to the internet. So what we do is we host the VM in a private network and expose it through a load balancer. I'll show a load balancer in another slide. So in that case, if you are hosting the VM in a private network, the only way we could access like directly to the VM, not through a load balancer. So what I mean by that is, let's say we can use load balancer to get traffic from the internet. Like if I hosted example.com, whenever someone goes to example.com, the traffic coming from the internet would flow through the load balancer. But let's say if I want to directly log into the VM and change some configurations and stuff, in that case, if the VM is hosted in a private network, we would have to use something like a VPN and connect to the VM through that VPN. So yeah, those are some issues with the VM, and also it requires manual configurations, because let's say I have hosted the app this way, and only way for me to send an update to the app is directly log into the VM and change the configurations there. Configurations as in like pulling a new code base and running it, or if it containerized, we have to pull the new container and run it. So that requires manual configuration. In this case, it could lead to some mistakes. So the way we overcome is we could use Cloud Run. So Cloud Run is a platform as a service, and the VM is an infrastructure as a service. So Cloud Run is actually a service provided by Google Cloud Platform, and there are some equivalent services to this in AWS and other services. So in AWS, they call it Fargate, if I remember correctly. Yeah, AWS Fargate, and it's somewhat equivalent to Cloud Run in Google Cloud Platform. So what Cloud Run does is, to deploy this here, we have to first containerize it. So this is a must. So to deploy in a VM, we don't have to containerize the app. We could just pull the code base and run it from there. But Cloud Run doesn't allow that. So we have to containerize the app and before we deploy it. And we can set like a scaling metrics for this Cloud Run instance. For example, we can configure it to, let's say, like 20 requests. So if we configure it to 20 requests, the single Cloud Run service instance will handle 20 requests. So when 21st instance comes in, it will deploy another instance. So it will scale horizontally based on the number of request counts. So that is another advantage. Another thing is, if a Cloud Run instance crashed due to a bug or something, it will deploy another instance by itself. So there are like health checks in Cloud Run where we can instruct Google to like check if the app is alive like every 5 seconds. So it will send request every 5 seconds, and if it's not responding, it will deploy another container assuming the existing one crashed. So now there is a load balancer. So the previous job of the reverse proxy is done by the load balancer. So the external traffic the coming into the app will go through the load balancer, and the load balancer will route it to the upstream Cloud Run services. Upstream means like the anything behind the load balancer, we call it upstream services. So for this load balancer, these are two upstream services. So with the load balancer, we can configure things like certificate manager and cloud dormer. So certificate manager is also a Google Cloud service. Certificate manager is what provide SSL certificates through Google Cloud. We call it managed certificates because it will automatically handle like updating SSL certificates, because SSL certificates usually update like in something like 3 years. I don't remember the exact time, but in set of period time it will expire. So the certificate manager, if we use certificate manager, it will automatically update when before the expired time reach. And Cloudama is like a security layer in GCP. GCP means Google Cloud Platform. So Cloudama is like a security layer. What it does is we can configure it to however we want. So by default, it doesn't do anything. So after enabling it, we have to add things like policies to make it do what we want it to do. So for example, we can add Cloudama policies to uh, things like block some regions and prevent some attacks. For example, there is a Cloud Run policy to for if you are aware with this attacks, these type of attacks. Cloud Dharma policy, there are Cloud Dharma policies to prevent those attacks. So we can enable those at load balance level, and it so if there is like a suspicious network request, it load balancer will block it from reaching the upstream Cloud Run services. So for most use cases, this might be enough. Like, but for like when it comes to enterprise applications, it things get like more complicated, because there can be situations where we need something like different environments for the app. For example, we need production, beta, and dev. So the reason is production environment is what the actual users will be using. Beta is like a replica of the production, where we can like test, and the development environment is also a testing environment, but it's dedicated for like development purposes. So another thing is we might need more control over the infrastructure, because this Cloud Run, as I said, is a platform as a service. So it's a, we call it a managed service. So a managed service, like a what managed service means is they handles the underlying complexity of hosting something, and they abstract it. But the downside to that is we have less freedom of what we want it to do. So it's very easy to get started on Cloud Run, but we have less freedom on like configuring things behind the scene. So in such cases, we have to move to something like Kubernetes. And with Kubernetes, things get a lot complicated. So as Chanak said, Kubernetes can be expensive because there are like a cluster management fee and the compute fee for the nodes used in the Kubernetes. So when moving to Kubernetes, it's not as easy as just containerizing the app. So in this case, we have to actually design a network architecture on how we want to configure things. For example, we have to this is a lot of like networking concepts you might learn comes into play. So for example, in here I would have to decide a subnet IP range I have to use, and the firewall rules I'll be using CloudNet to allow external traffic. Sorry, CloudNet to allow internal services to uh, call outside services like the internet, and the load balancer to receive traffic from the internet. If you are not aware of these things, just let me know, so I'll explain about them more. So when moving to Kubernetes, that is important. We have to configure the architecture of it first, because it's get complicated and we don't want to miss something important, especially things like firewall rules. If we didn't configure firewall rules, anyone would be able to like the ping our internal services. So also the Kubernetes cluster can run in a public network, but that is not how it should have done. So what we usually do is we host the Kubernetes cluster in a private network. So similar to a VM, when we are hosting it in a private network, we have to use a VPN to connect to the Kubernetes cluster, because there is no other way. The only way is have a VPN server within that private network and access it, because everything else will be blocked from the firewalls. And the next thing is we have to create Kubernetes configuration files. So the Kubernetes configuration files are called manifest files. Those are in YAML format. I'll put that in the chat. So it's somewhat similar to JSON, if you have heard about it. So in YAML format, we have to create our cluster configurations, and we are calling it manifest files. So this is what it would like. Let me see. Yeah, so this is what it looked like in an enterprise project. So in here we have like the 3 different environments like we planned before for production, beta, and development. And we do, after the development stuff, we push the changes to development environment, and from that, if development environment is stable, we push it to beta, and on the beta we test the app, and if all good, we push it to production. In this example also, we are using a load balancer to get the traffic, and the only difference is in here, instead of Cloud Run, we are using a Kubernetes cluster. So here is the Kubernetes cluster, and this resides in a private network, and within this cluster we have these boxes. We call each of these like environments a namespace. So a namespace is like a way we group like a services into multiple sectors within the cluster, so they wouldn't collide with each other. So as you can see, I have this app service 1 across all of these namespaces, but it wouldn't collide with each other because there are in multiple namespaces. So when like the actual user uses this app, which is the production app, the traffic would be routed to the production namespace, this one, and the configuration to route the traffic is done from the load balancer. So we configure the load balancer to uh, route the traffic to the production environment when example.com is called. So when beta.example.com com is called, the traffic will be routed to this namespace. So this is the Kubernetes cluster, and the cluster resides in a private network, and within that private network we have the cloud NAT. NAT is, if you don't know, NAT stands for network address translation, and what it does is it hides the internal IP addresses of a private network when the private network calls for the outside world. For example, if you have like a SLD router at home, when you're going to the internet, your actual machine's IP address would be hidden to the internet. What the internet has is the IP address of the router. So the NAT is the mechanism that allows that. So something like SLD routers and the dialog routers all have this NAT enabled, and that this is what hides the internal IP addresses of the services. So to these services to call, let's say one of the in example.com map, I have to call like a third party API to fetch some data. So if we want to call that outside third party API, it would have to go through the NAT to call that, because there is no other way for this to access internet, because load balancer only allow traffic, like if we configure it to receive web traffic, it will only allow web traffic into the like particular namespace. Load balancer doesn't allow traffic to go out from an internal service. That is done from the cloud NAT. And firewalls are also connected to the private network, and if you have a database for the app, and it might there is a service called Cloud SQL in GCP, so that can be used there. And for caching stuff, we are using Redis. This is actually called memory store in GCP, so it's equivalent to Redis, but not exactly Redis, but all the Redis APIs are working in here. So most of the time you could get away without having Redis. Just having the database is enough. Redis comes when you want when you want to cache some stuff in the app for better performance. That's where Redis comes into play. And if you have like AI integrations in the app, so those stuff are not hosted within the cluster. Those resides in the those doesn't resides in the private network. The reason is, let's say if we host an AI model for each of these namespaces, and like let's say we have to do something called fine tuning for an AI model to perform what we want to do with it. For example, if we take like a generic AI model, something like ChatGPT, OpenAI, or like a Google Gemini model, if we that is a generic model that only knows about generic stuff, but if we want to integrate this into this example.com map, that AI model doesn't know about this specific app, so we have to teach it about our app to the AI model. So that is done through fine tuning. So when you are doing that, we don't want to fine tune for each of these environment, because specific like a single fine tuning job could like cost something like, it could range something like 10 USD to like 10,000 USD. So we don't want to fine tune for each of these environments. So what we do is we keep the AI models outside of the network, and we call it from the namespace. So another thing is we have cloud storage, which is where we what's an example? Yeah, so let's say you have an app where you want to create when you are yeah, so let's say when you're signing for an app, we configure it allowing users to upload a profile picture of them. So that profile picture has to be stored somewhere. We can't store it in a database because that is database the isn't intent for that. This database is for text based content, for things like images, videos, and those binary stuff. We store it in cloud storage. And so I remember someone asked about data science, and data science people lot of the time uses BigQuery. So this is a lot of analytical stuff happens. If we this have like lot of applications to it. For example, if we have something like Google Analytics enabled in our app, we can configure Google Analytics to export its data to BigQuery. So if we have like a dedicated data science team, they will go through these exported analytics from BigQuery and like try to make predictions of like what are the customers want and provide like how we move forward with the app. And also when dealing with AI depends a lot of lot AI. An AI model is only as good as its dataset. So the dataset is very important for an AI model. So to we since and the dataset we need for an AI model is very huge, we can't afford to store it in something like a traditional cloud scale database. We have to store it something like BigQuery. BigQuery is by definition Google call it data warehouse. So it's not like a database, it's a data warehouse where we store like a data for a long time. So if you are gathering data for an AI model to train on, that data will be stored in BigQuery. And also if you already have an AI model and you want to store like a data of how like users use it and like the chat history of users, those should be stored in BigQuery, not like a regular SQL database. So same as previous example, the cloud DOM can still be used with the load balancer with Kubernetes. Yeah, so this is what I wanted to cover on my side. Do you have any questions? ප්‍රශ්න සිංහලෙන් වුණත් අහන්න ඒක ප්‍රශ්නයක්. Also කලින් අහපු තැන් දේවල් වල මේ ඒ කියන්නේ ටෙක්නිකල් මදි නම් ඒත් කියන්න ටෙක්නිකල් වැඩි නම් ඒත් කියන්න. මොකද දෙපැත්තටම එක්ස්ප්ලেইন කරන්න පුළුවන්.
කට්ටියට අනිවාර්යෙන් ongoing projects ඇති projects වල issues තියෙන්න පුළුවන්. cloud integrate කරන්න ideas තියෙන්න පුළුවන්. ඒ දේවල් ගැන මොන හරි අපිට කතා කරන්න පුළුවන් නම් අපි මේ time එක කතා කරමු.
pops up. Can I? Yeah, let me share my screen. Yeah, hope you can see the screen.
Yes, it's visible.
Yeah, so pops up is it's actually implementation of Apache Kafka. So this Google, like the Google native way of using Kafka is called Google PubSub. So this PubSub stand for publisher and subscriber. So this is a way subscribe. This is a way we manage event-driven applications inside our infrastructure, and not just event-driven. Let's say if we want to handle like a very large number of uh, data coming in, and it doesn't have to be synchronous, then we could use PubSub. So let's say for example, this is widely used in game engines. So let's say for example, I have a PubSub. I'll just call it queue, but the exact word for this is not queue. I'll explain that later. So we have a PubSub queue here, and someone can send request to this PubSub queue from another service, and there will be multiple like subscribers, like they are like listeners. They will listen to the messages coming from this PubSub queue. This is actually called PubSub topic. I'll just put it there. So the reason we add this like the middle ground is there is a publisher here. Publisher will publish messages and the receiver end is the subscriber. And the reason we add this middle part is, let's say these messages, like the messages coming in, this can be like there can be like 100,000 or even more messages at once. So we can't or don't want to handle all of it at once. In such cases, we can use PubSub. So what it does is this subscribers can run in two modes. One is the pull, one is the push. So in when it's running on pull mode, what it does is it will, when it is the service is free, it will pull one message from this topic, it will process it, and when it's done, it will pull another message. So when in pull mode, this subscriber is this subscriber doesn't get overwhelmed because it runs at its pace. In push mode, this what happens is the PubSub topic will like forcefully push incoming messages to the subscriber. So it doesn't wait until the messages are done. So let's say in there are also like a lot of configurations we can do with this. There are like things like F5F4. This means first in first out. So if the message comes in first, it should go out in first. There are different like ways we can configure it. Something like in game engines, let's say an event is happening. Let's say someone is going from like this place to this, and when it's happening, like all of these are like, so from the game what is happening is this actor doesn't directly go from here to here directly. It goes from it takes all of these steps to go here. So behind the scene, what the game engine does is when it take a step, it will push its state to a backend server. So backend server can be this publisher, and publisher will publish it to a pub subtopic. In this case, we don't use FIFO because we don't want first in first out in this case, and the reason is, let's say I took all of these steps to get here, like this, and this. I'll put this in different colors. No, it's not clear. So in this case, let's say in the I make a move in here in this red rectangle, and when that happens, the event of this happening, the place, the new place I'm in, get pushed to the backend server. Let's say for some reason this gets delayed. This message gets delayed receiving, and this one reaches first. That can happen when due to like network connectivity issues, depending on the ping, those type of stuff can happen. So in that case, we don't know when a request comes in first, that doesn't mean it should go out first from here. So in those cases, we don't use first in first out. There are like some edge cases like that. We have to use like different algorithms within PubSub. So the basic idea is when when there are a lot of traffics coming in and we want to manage how the traffic should be handled, then we use PubSub. And when there are like when the services are not, we don't want to spend a lot of money on these services to process these messages. In those cases, we could use this pull method, because this will pull messages at its pace. Like it doesn't like the crash the whole system when a lot of messages are coming in. So that is the idea of PubSub.
So hope that is clear what Savin explained. And we have some other questions as well in the chat. The first one is which cloud platforms are most commonly used in the industry today? So I would say from the market cap, it is AWS, then the Azure, then GCP. So the majority of the market cap is conquered by Amazon Web Services, AWS. But it depends on the way you are going. Like, so Amazon is good at their infrastructure and services, and they have a very well-known history. Then from the GCP side, but their mainly focus is the AI and ML side. So with the GCP services, they are continuously giving more AI stuff, especially the modules in the Vertex AI section. So yeah, from the market cap, that is the answer. And when you are choosing a cloud provider, so you should be aware about what you are going to build. Is it AI biased? Is it infrastructure biased? So that depends. Hope I answered that question. Sabina, do you have anything to add?
Yeah, one thing to add to that is when you're choosing a cloud platform, so ideally use one is AWS, but Google has an edge because Google AWS doesn't have like an AI model as capable as Gemini to compete with it. But Google does have an AI model called Gemini. So we can natively integrate Gemini from Google Cloud Platform, but we can't integrate an AI model natively from AWS because they don't have one. So in such cases, it makes sense to use something like Google.
Plus, I think we have to check about the history of downtime as well, right, Savina?
Yeah.
And the other question is, with the rapid advancement of the AI, do you think AI can replace software developers in the future, or will it mainly support and enhance role of developers? So from my point of view, so AI is replacing developers, but not the real software engineers. AI can develop softwares, develop websites. Within few prompts, we can do that. But as software engineers, when we look at those code, so there are still something to improve, and especially with architecturing, I don't see AI replaces that kind of roles, like architecturing, like the things that Sabina showed. How do we integrate multiple services, policies together to build an sustainable infrastructure? So in that case, AI still struggles. Even we give the specific permissions, AI is still not building the infrastructures, the services that we want with the expected standards and levels. So yeah, my point of view is that uh, if you want to survive, if you want to be a good software engineer, so you need to be smart enough to do more than what AI is doing. You need to think, you need to imagine something more that AI is not capable of. Savin, any ideas?
Yeah, I think you pointed out the most of it. And another thing is AI is developed from the code human wrote. So it's like a statistical model. So in theory, it can't be better than the best software engineer in the world because it trained on the data software engineers in general like wrote. So if you become like the top 1% engineers, they can never be replaced because the top 1% of engineers doesn't have enough uh, data to model like train a model. So we can't train a model that represent top 1% engineers because we don't have enough data. So the most of the data is coming from like the average developers. So yeah, that's the point.
Yeah. And the final question is, what key skills should undergraduates focus on if they want to build a successful career in cloud-based and AI technologies? So the key skills that today's undergraduates need to improve is, how do you align with AI? How do you integrate? How do you get maximum support of AI without distracting? Because when we are doing interviews and stuff, we see that some are overusing AI, and when we question, they don't have the real idea what they have done. They have done something, but they don't have the idea. And on the other hand, there are some people who don't use AI. So they learn, but very slowly. So their progress is very slow. So it is hard to keep up with that kind of people as well. So my idea is you have to be in the middle. You have to get maximum support of AI, but AI should not distract you. AI should not make you fool. That's the main point. And when you become faster by using AI, you can learn a lot. So maybe you can be a data science student, you can be a computer science student, software engineering student. So be a specialist on that area. That is great, but don't skip the uh, the area around you, maybe. So let's say if you are a information management student, don't skip the software engineering part, because with this AI, we can get help from AI and learn faster all the stuff. Because going forward with these tools, all the roles, currently we have front-end developer, back-end developer, DevOps engineer. But going forward, they are kind of merging together. All are doing by one person. Why? Because we have these tech tools, AI models. So they are there to help us. So we need to mindfully manage those tools to do our work and learn. So that's the main point I would like to highlight in that case. Don't stick to a one area. Learn everything as much as possible you can, and you need to practically try out by applying those stuff. For example, let's say if you go to AWS, you have some free tier, some free packages that you could use and try out their services. In GCP as well. So if you sign up, you will get I think $300 credits to try out GCP. So that is more than enough to try out and learn things. So the best thing is trying out the technologies that you can try out. So, anything to add?
No, I think I agree with you, Chanaka. The main thing is trying things out. So you you can't really like prepare for everything beforehand. You have to like actually
Yeah.
start doing it to get better at it. So I would suggest something like create like a free account in GCP or AWS and start doing some projects, and like you would learn a lot more with that than like doing like watching something like a tutorial on YouTube.
Yeah. And also we have a new question. What are the signs of a good intern candidate? What are the things recruiters focus on CV and in the interviews? Yeah, that's a good question. So the first place that we identify the candidate is by CV. So the CV should be quite clear. The CV should contain what you have done, not much about what you have done in theoretical aspects. That is important, but in this era, we are more focusing on the practical aspects. So, what are the projects that you have done? What are the tech stacks? What are the special libraries that you have worked? What are the solutions that you have provided? All those details should be included in the CV clearly. So, by looking at that, recruiters can identify. So, yeah, okay, that this person has done something other than the regular people. This person has done something extraordinary than the regular interns. And after that, so when you are coming to interviews, so if you have mentioned anything in the CV, so that will be the point we are starting questioning. So all the points that you have mentioned you should be able to explain by yourself. So if we feel like so you have mentioned something, but you don't have the proper idea, so we don't know whether you have done that also. So in that case, you might not get selected. So if you are doing something, have the proper idea, have the full picture, and do the development and learning stuff. Yeah. Savin, anything?
Uh, no, I think you pointed out most of it. The first thing is like a first impression of the CV, like Chanak said, because it will be reviewed from the HR people, not like engineers. So HR people might not be as technical as engineers, so it would so for HR people, this for the HR people, CV should be like uh clear. It should have a good first impression. And when during the interview, apart from what Chanak said, I think just be honest is the most important thing. So if you don't know something, just say you don't know. If you know something, explain it well. That's it.
Any more questions?
Thank you so much, Mr. Chanak and Mr. Savina, for your valuable insights. We truly appreciate the time and effort you put into today's session. Now, to formally conclude today's session, we would like to invite President of the Society of Computer Sciences, Mr. Stina Godavithana, to deliver the vote of thanks.
Good evening, everyone. On behalf of the Society of Computer Sciences of Sabaragamu University of Sri Lanka, it's my great privilege to deliver the vote of thanks for today's Tech Talk v3.0 session on cloud-based AI technologies. First and foremost, I extend our deepest gratitude to our distinguished speakers, Mr. Savina Veerasurya and Mr. Chanaka Ramanayaka, Associate Tech Leads at CodeMind Private Limited. Thank you for sharing your expertise, insight, and real-world industry experience. Your contribution added immense values to these sessions, and we sincerely appreciate your time and dedication. A special thank you also goes to CodeMind Private Limited for partnering with us, our knowledge partner, and for supporting this event. We would like to also express our heartfelt gratitude to the Professor S. Vasantapriyam, Dean Faculty of Computing, whose continuous gratitude and encouragement make event this like possible. Our sincere thanks extended to the head of the Department of the supports for motivating students to participate and grow through this academic engagement. A warm appreciation is also extended to our senior treasurer, Ms. Kumudu Vijayaratna, for your support and supervision and each of our activities. I would like to also extend our appreciation of all the lecturers of the Faculty of Computing and also to hardworking SOCS volunteers. Thank you for your commitment and teamwork. Finally, to all participants, thank you for your active engagement. Your presence truly made this session meaningful. Once again, thank you everyone for contributing to success of Tech Talk v3.0. We look forward to seeing you in upcoming events. Thank you. Have a wonderful evening.
Thanks all, and thanks for having us today. Yeah.
Thank you for the thoughtful vote of thanks. Is there anything further you would like to add before we conclude